Okay, so today we are going to solve past exam IMAT 2020. Okay, let's go. We will start with the physics mathematical section, and we will solve all the physics questions first. Question number 55. Okay, so we have here a rocket. A rocket is launched vertically from the surface of the Earth. As it leaves the launch pad, the total mass of the rocket is, and it's all of its content is m. The gravitational field strength on the Earth is g. The rocket motor provides an upward vertical thrust, a push, t to the rocket. The force, upward force, is t. The question is, what is the initial vertical acceleration of the rocket? Acceleration a of the rocket when it leaves. So we have F equals ma, or sigma F like the total sum of all the powers. So you need to choose one direction, one dimension. We will take y, yeah? So you have like, x, y, z. So we will take like upward, which is like y or z, not important. So we'll take this z, let's say z, okay? So we'll take one dimension. On this dimension, because we speak about vectors, so on these dimensions you have t minus mg, this is the sum of all the forces, equals ma, and they ask about the acceleration, so a equals t minus mg divided by m, so it's like t divided by m minus g, yeah, answer is a. Any questions?
No.
Okay, let's go back one step to make it more. T divided by m minus mg divided by m. Here the m cancels out, so we have this, and the answer is A. Okay, question number 58.
A beaker contains 1,000 grams of a liquid that is stirred at its boiling point. At its boiling point, a 100 watts electric heater is completely immersed in the liquid. The heater provides the liquid with thermal energy, and 200 grams of the liquid changes to vapor in 1,600 seconds.
Exactly. Yeah.
What is the specific latent heat of evaporation of the liquid? Assume that no thermal energy is transferred to or from the surroundings, and no vapor condenses.
Okay, let's try to understand this question. Latent heat, Q equals ml.
Yeah.
So Q is the energy, thermal energy. Yeah, this is the thermal energy. M is the mass evaporated. We have here like 200 gram of mass. L is specific latent heat. This is like what we need to find. Okay, the energy is power multiplied by time, because power actually is energy by time. Okay, so let's understand what we have here. So we have here time 1,600. Let's try like with another marker. So we have time 1,600 seconds. 200 gram, we wrote here 200 gram. You have 100 watts power applied for 1,600 seconds. So you can calculate here the Q, okay, the energy, how much energy. Let's calculate how much energy we have here. So if we gave it 100 watts, 1600 seconds. So we will have here how much? 160,000, yeah, joules, yeah.
Yeah.
So we have 160,000 joules. What they ask about, what is the specific latent heat evaporator of the liquid? L. So L, so we have the Q is 160,000. M, the baker contains 1 kilo, so like 1,000 grams multiplied by L. So our L is actually, take out 3, this is 160 joules per gram. So the answer is B, 160 joules per gram. So let's explain what happened here. So you have a beaker contains 100 grams of liquid. So you have a 1 kilo of liquid. And this liquid, you don't know like what is the specific parameter of this specific liquid. But what you do know is how much energy you put in this liquid and how much from this liquid evaporated. But you don't exactly know how much energy, you know how much power and how much time. So power is energy per time. So actually energy is how much power you put in some time, multiplied by time. So 100 watts, 1,600 seconds, you put 160,000 joules. If this 160,000 joules evaporated 200 grams, no, evaporated, sorry, 1,000 grams. So actually the specific number here is 160. Yeah. 1 second. So okay, so we here divide by 1,000. This is the full mass of all the liquid. What we should write in the equation is actually the mass of what was evaporated, which is 200 grams. So 160 divided by 200, we have like 800. This is the specific, so the answer is D. Okay, so 1,000, this is all the material, all the liquid. In the equation we need to write the evaporated mass.
Yeah, because they specifically asked about evaporation of the liquid in the question. That's why.
Okay, so next question, 59. It's about waves. Let's go.
Yeah. The diagram represents a concave mirror where F is the principal focus and F is the focal length. Okay. The mirror is used to produce an image of an object. Which of the following statements are correct?
Okay. So let's see. Concave mirror. This is a concave mirror. What we know about concave mirrors? Let's remember. We have the point F. The point F is a point called focus point, and we know about parallel waves. So if a wave comes to this mirror parallel to this like axis, you know, this perpendicular axis, yeah, from the middle, it will reflect through this point. And another law, if any wave comes through this point, it will reflect parallel. So this is two laws. Okay, So regarding the image, so it depends if you are before or after some point. The image can be bigger and smaller and inverted and not inverted. 1 second. So if you have an image, this image as it is, it's called looks upright. If it looks upside down, so it's called inverted. Okay, you have real, you have virtual, and you have larger and smaller. So larger is like just more big, you know, and smaller is more small. Okay, to explain. Okay, so let's go to another page and I will explain everything here. So you have here the mirror, the concave mirror. You have here F, you have here 2F, and let's see. So at this point you have no image, because you know all the arrows, all the come through here. So at this point, actually if you draw, it's like also can give you some idea of how the image looks. This is one arrow, this is one light wave, and this is the second one. Okay, so let's make let's break it down. So in this point there's no image. You can see that all the lines pass from this point, like it's impossible to you cannot have an image here. What about between F and 2F? So between F and 2F in this area, okay, this is F. Let's write it like this. No image and F. Okay, between F and 2F in this area you have real, image, large, and inverted. So if you look at these arrows, yeah, they are inverted. Look, this line 1 is down, so you see what is up, you see it down, it's inverted. Yeah, what is up you see down, it's inverted. So here between this and this it looks like this. Okay, I will after check it, write it again. Let's continue. So real, large, inverted. What about 2F? At 2F, so why it's larger? Because the distance from here till here, the distance is smaller, so you see a larger scale. The same scale comes at 2F exactly. This is real, same scale, and what inverted, of course. And because after 2F the arrows will be more far, so in this here you will have real, smaller and also inverted. What about between F and the mirror? You will have the same image, so it will not be inverted, it will be upright. Larger because the arrows are condensed, like they are in a smaller area, so this is larger. You can, like with the same eye, see more information. 1 second. Okay, so the last thing here is that between F and the mirror, the image is not real, it is virtual. It's called virtual. So the definition of real and virtual is like real is when the arrows, after the arrows meet, and virtual is before the arrows meet. This is the definition between real and virtual. You can say also that in this area, so another way to understand the difference between mirror and F and after F, that this side is mirrored but this side is not mirrored. So real, this is a real image, not mirrored image. Virtual is mirrored image, and this is a real image but upside down. Okay, so let me again. So you have here you have here F to F. So what we have here? We have here, if this is the real image, okay, so what you will see here, you will see a shape bigger, yeah, you will see a shape like this. Here you will see a shape like this. Here you will see the same size. On 2F you will see the same size. Here you will see the same size, and here you will see smaller, yeah. Again, this is also flipped and smaller. Here you will see like this. That's it. And here no image. Okay, so here is bigger, mirrored, virtual, upright. Here inverted, bigger, inverted, bigger, real. This is not real, this is virtual, this is real. Here's the same size, real, up inverted, and here's smaller, real, inverted. Actually, the size, so about the size. If this is the rays in the beginning, so if you have the rays smaller, the image is larger. And if the this is the same size, normal size, and if you have them like expanded like this, so the image here will be smaller actually, like in not in concave mirror, like on the other kind of mirror, on the convex mirrors. Okay, good. So this is like a summary of all this subject. Let's see the question. Okay.
Yeah.
So what we have here, some statements. Let's see the statements. Statement number 1.
Yeah. Incident rays traveling parallel to the principal axis always pass through F after reflection.
Yeah, of course. Like if they are parallel, to the principal axis. This is a principal axis. They are parallel, so they reflect through F. Okay, one is good.
Yeah.
Next.
Incident rays passing through F always travel parallel to the principal axis after reflection.
Correct. 3.
Okay. The image formed is always inverted.
So between F and the mirror, it's not inverted, so it's not true.
Yeah. The image formed is always real.
Not
Also no.
true, because between F and the mirror, it's
Yeah.
virtual.
Yeah. The image formed is always larger.
Larger than the object.
Yeah,
No, no. Beyond 2F, it's smaller.
yeah.
Beyond 2F. So it is not true. So the answer is 1 and 2.
Yeah, the word always is an indication that it's not correct.
The what? Always, yeah.
The word
Always,
yeah.
Always is hard to achieve, because
Achieve.
most probably is, yeah, but it's not always. Always is not correct. Most probably.
In this question, I mean.
Yeah, in this question, yeah. Okay, so that's it for this question. Nice. Next.
Okay.
Okay, so question number 60, actually the last one on physics. Yeah, let's go.
Yeah. A boat crosses a river that has straight parallel sides. In still water, the boat has a maximum speed of 4 meters per second at maximum power. The boat is aimed at a point directly across the river from its starting point. The river flows at constant speed of 3 meters per second parallel to its sides. What is the speed of the boat as measured by a person stationary on the bank? And what is the angle at which the boat travels, measured from a line at 90 degrees to the bank?
Okay, so the boat goes in one speed, 4 meters a second, like this, yeah?
Yeah.
The boat is aimed at the point directly across the river. Okay, from the starting point. The point directly across the river. What is the speed of the boat as measured as a person stationary on the bank, and what is the angle at which the traveler measured? So the real speed will be combination from with like 4 and 3. So you have 4 and you have 3. So actually this is like will be 5, yeah, by fast proportions of Pythagoras, yeah.
Yes.
So this is 5. So you have like here this is 5 and this is 5 and this is 5. And you need just the angle. So the angle will be this here, cosinus. So they want cosinus or what they want? They want the angle actually, alpha. So you can choose, if you have the answers cosinus, yeah. So you can choose cosinus, So cosinus alpha equals okay, so the cosine of alpha, actually this is the hypotenuse divided by the adjacent. Yeah. So this is the hypotenuse.
Isn't it the adjacent divided by the hypotenuse?
So let me see this. Yeah, actually, yeah. Thank you, correct. And you have the adjacent. So the hypotenuse multiplied by cosinus alpha equals the adjacent. So actually the cosine by itself is the adjacent, which is like 4 divided by the hypotenuse. This is 5. But this is a cosine, so you have you need the arctangents of cosine, or actually, so alpha equals cosine the inverted function of it. So looks like A is the right answer. Yeah. Let me check.
Yeah. Let's check.
This question 60A. Yes, that's great. So let's go to math. So the math questions. We start with question number 53. Okay, let's go.
No. Which of the following is equal to this equation?
Okay, so each time you have the square root, you can solve it by actually what we wrote last time, a square minus b square equals a plus b multiplied by a minus b. So if you have a square root here, so you can add here, multiply by 2 minus square root of 3, and up 2 minus square root of 3. You see the answers have square root of 3 in the nominator, so this is a right way to do so, you know. Why? Because now instead of this, you can have 2 square, yeah, minus what? Square root of 3 square, which is 3.
Yeah.
And you have 4 minus 2 square root of 3. So let's see what we have here now. So 2 square is 4, 4 minus 3 is 1. Again, yeah, I will make it slowly. So you have 4 minus 3, this is 1.
Yeah.
So 4 minus 2 is 3, 4 minus 2 is 3. So actually 1 you can just not write it. So you have 1 minus 2 square root of 3. B. Okay? Again, the trick is, if you want to transform the square root from the denominator to the nominator, you use this equation. Okay?
Yeah.
Okay, so instead of square root in the denominator, you have it now in the nominator. Okay? So this is easy one. Let's go to the next mathematical question. So you see, like, it's not a high level of hardness, but you have tricks and speed. You need speed and tricks. Okay, let's go.
Yeah.
Yes.
What are the coordinates of the turning point of the graph of the quadratic equation?
Okay, let's remember a few things here. Okay, so let's remember, like, in relevant equations in general. So if you have ax squared plus bx plus c, so the turning point, or the maximum or the minimum, you make a derivative and equals to 0. So you have 2ax plus b equals 0. So x equals minus b divided by 2a. Okay, so in this case you have the turning point x coordinates are minus 5 divided by 2 multiplied by 2. So this is like minus 5 on 4. This is the x coordinate. So substitute it in the equation, you will have the y. 2 multiplied by minus 4 square plus 5 multiplied by minus 5 on 4 minus 2. So this will equal how much? You have 2, 25, 16 plus minus 25 on 4 minus 2. You have 50, 16, 16, 100. It's okay to continue?
Yeah.
32, 16. How much it will be? Minus 50, minus 83, yeah? 82.
Yeah. 82.
116. 8 and 41. So you have minus 5 and 4 minus 41 and 8. This is D.
Let's see. B.
B. B. Let's check it if it's the correct answer. Question number 54, B. Okay, next. Next one. Okay.
Okay. What is the value of x?
Okay. The value of x. What we have here? We have x in the power, inside the power.
Yeah.
Look, you need to break it down to the prime numbers. This is, I think, always like the best way of simplifying things. So you have 8. What is 8? 8 is 2 in the power of 3. What is 4? 4 is 2 in the power of 2.
Yes.
And you have here also 2 in the power of x plus 3. So, what we know that x in the power of a in the power of b equals x a b. And you know the rest, yeah? A plus b. So let's do it. So you have here also like x minus a is 1a, and x1 divided by a is the square root of a. I think this is the most basic relevant equations. Okay, so let's do it. So you have 2 in the power of 3, 2x plus 3 multiplied by 2 in the power of minus 2, 3x minus 2 in the power of x plus 3. All okay till now?
Yeah.
This is multiply. So 2, 3, 2x, 6x, 3, this is 9. Sorry, this is plus now. Minus 6. This is minus 6x minus 2x plus 3 equals 0. Actually, let's make it equals like this better. So 6x, 6x, you have 2 in the power of 9 equals 2 in the power x plus 3. So from here, you can just actually say 9 equals x plus 3. Or you can put ln on the both sides. It's the same. Yeah? So x plus 3 equals 9. So x equals 6. Again, you can apply ln, logarithm, or ln on both sides. So the power will go down. Yeah? And you have ln 2. And the both sides, it cancels out.
Yeah.
Okay. Next question. Okay, so yeah, 39, please read the question.
Yeah, 39 male students and 36 female students were asked how many meals they had eaten in the school cafeteria during the first week of the term. The results are shown in the table. What is the value of x, the female?
Yeah, so we made like, to reach this, like how they calculated this 2. So 2 equals a1, a2, a39 divided by 39. And x equals females b1, b2, b36 divided by 36. And what is 3 and 1/5? This is a1, a2, a39 plus b1, b2 until be 36 divided by 39 and 36 total.
75, which is 75.
What?
Is this 75?
Yeah, okay. How much? 31 and 4? 75. 80. No? 70? 75. Okay? So you have 75. But how to reach from like this here to here? Usually, when you have... So I can explain it in two ways. The first way is you say, okay, this is the average of the 39 students. X is the average of 36 students. So you make average of the averages. Yeah? And this equals 3 and 1/5. You can have the answer like this. Another way of thinking about it is you take this one and you say, so sigma A equals 2 multiplied by 39 and sigma B equals X multiplied by 36. And what we have here actually, this is sigma A, sigma B. Okay, so this equation here actually is 2 multiplied by 39 plus X multiplied by 36 divided by 39 plus 36 equals 3 and 1/5. So actually it's the same equation. So, or you go by the definition of mean or like average here and the total, and you can reach this equation, or you say all students also means or also equals the average of the averages. It's the same thing. So let's solve it. So you have 2 39, you have X 36 divided by 39 plus 36 equals 3 and 1/5. Okay, so how much it will be? You said here is 75. Yeah? 3, how much is the 3 and 1/5 is like 5/16, something like this.
Yeah.
2 times, this is 78 plus 36x. This is okay? Okay. So you have 78 plus 36x equals 1675 divided by 5. 36x, I would take it step by step. 1675, 5 minus 78. Okay, this is 5. How many 5s are here? 50. How many 5s are here? 15 5s?
Yeah.
15 times 5. So x equals 1615 divided by 36. Okay, let's do this. 16 and 15, how much? Okay, so 16, 15, you have 30, 8, 6, 1, 0, how much?
240.
240. 78 on 36. So 240, 78. This is how much?
2. And then,
Yeah. So this is like 10. This is 2. This is 13.
162.
60? Yeah, 62. 162 on 36. Now 162 on 36. How to solve this one?
Long division. Are we gonna do now?
Look, multiply by 4. How much 4? How much are 4 times 36? 4 times. 4 times 36 are 120, 100.
144.
144. This is how much we said? Sorry.
Yeah, so it's 4 times. Yeah.
4 times. So 144. So how much we have here? 22. Yeah.
Yeah.
So you have like this is it. Like no more to. Okay, let's see. 2236. You have on divided by 6. This is 5. 6. It's not. No, I can't divide it by 6. Maybe 12. 12. No. By 2 it's 11. By 2 it's 18.
No, wait. I think we did something wrong here.
Should
In the long division, it's not 22.
It's not 22?
No, it's 18.
Oh, 18. This is it. I saw this 140.
4.5. Yeah, it's 4.5.
Yeah, so where is the 18 now?
Because, 18 is half of 36, so it's 4.5 the answer for the long division.
So this is like 4 and 18, 36. So 4.5. Yeah? Okay, 4.5. This is A. Cool. Okay, so that's it for today. We made 2020 exam, physics and mathematics. See you next time.
Yeah.
Bye-bye.